thermal energy in a liter of helium at room temperature and atmospheric pressure, then we have to repeat the same calculation for a liter of air. Okay, let's start with helium. And we know that the thermal energy is equal to 1/2 N, which is the number of molecules, times F, which is the degrees of freedom, times K, Boltzmann constant, times the temperature. Okay, now for helium, this is a monoatomic gas. There's 3 degrees of freedom. That is the velocity is translational, and it has 3 components, 3 quadratic components, Vx, Vy, and Vz. So that means F equals 3. Now K, we already know the temperature is room temperature. That's 300. We need to figure out the number of molecules. We have the volume. This is an ideal gas, so we know that PV equals nRT. We know that the pressure is atmospheric, and so to find N, or we could just use NR or just NKT, right? And so that means N would just equal PV over KT, and we can just plug this. So the energy would be 1/2 N is PV over KT times F times KT, and we could cross these out, so we get 1/2. Now we plug in the numbers. Atmospheric pressure is 1.01 times 10 to the 5th. This is 1 liter, meaning 1 decimeter cube. If we change it to meters, we multiply by 10 to the minus 3 to make it meter cube, and the degrees of freedom we said is 3. Plugging these numbers in, we get 151.5 joules. Now for air is made up of nitrogen and oxygen, and those are both diatomic gases. And so for diatomic gases, we have 5 degrees of freedom. So the only difference is F equals 5. That is, we have 3 translational and we have 2 rotational degrees of freedom due to being an atomic gas. The reason there's 2 rotational versus translational because of reasons that has to do with quantum mechanics that I can elaborate on it in my recordings in quantum mechanics. The molecule is not allowed to return on the axis it's aligned with, on its own axis. So that prevents 1 degree of freedom in the rotational sense. So yeah, we have 5 degrees of freedom. So you could do the same thing we did in the first part, except 5 degrees of freedom, and the answer would be around 250 joules for air. That concludes this problem.